Hey guys, I decided to do a quick recording just to show you how to do the graphing again when we discuss the vertical motion. So as you can see, I have chosen the problem, one of the problems. I believe it is the first problem yesterday, on Tuesday's class that we discussed, where you have an initial velocity of 15 meter per second. And then, yeah, that's pretty much it was given to us. And we were supposed to find the time it takes to go to the maximum point. So we've used the equations, V initial equals, V final equals V initial plus AT equation. And then we found out T equals to 1.53 seconds. Check your notes, all right? And then we use delta x equals V initial t plus 1/2 AT square equation. And we found out delta x, or you can call it delta y, it doesn't matter. Since it is vertical, I'm taking it as delta y. And the answer we got was 11.9 and something. So I'm just going to round it so that we have the answer as 12 meters. So this is what we did yesterday, right? And also right next to the table, you can see that I am using up as the positive direction. So we were supposed to draw the displacement versus time graph. So let me draw the axis. So this is the displacement, DISP, and then here I have the time axis, right? So when you have something like this, the best thing is to mark the coordinates. So the first coordinate that we know is when time equals to 0, the displacement is also 0 right here at the point A. And then when time equals to 1.53, the displacement is found as 12 meters. And if you mark the coordinate, it is somewhere over there. And when time equals 3.06, that is like when you multiply this by 2, that gives you 3.06 somewhere over here. It is back at point C. So here are the points A, B, and C. And you guys know that displacement versus time graph, the slope gives us the velocity. So you know that at the top, the velocity is 0. That means the slope also has to be 0. So a slope 0 means a flat line, right? A line parallel to the, the time axis. And we know the shape of a decreasing velocity. And here we do the first half going from A to B. Now going from B to C, what happens is, now the velocity is again increasing. So at point B, the speed or the velocity is 0. And now it is heading back. So it is gaining velocity. And when it reaches all the way to the point C, or in other words, the same point where it started, there you have a velocity 15 meter per second pointed in the downward direction. Therefore, you have it as a negative 15 meter per second, right? So we are drawing a increasing velocity pointed in the opposite direction type of a graph. So that's what it looks like. So if you are looking at a slope over here and here and there, you can see definitely the slope is decreasing. And going from the other way, here you have a 0 slope, there you have somewhat, and then the slope is getting steeper and steeper as you go, meaning the magnitude of the velocity is increasing, but this is a positive slope, that's a negative slope. So here you have a positive velocity, there you have a negative velocity. So this is how you explain this graph. Now the corresponding velocity versus time graph, again, you mark the coordinates. So here you have the velocity, there you have the time. So at 0, 0 point, the velocity, at when time equals to 0, the velocity is 15 meter per second. So let's go along the y-axis and then there we mark the 15 meter per second velocity, just like that. And then when t equals to 1.53, 1.53, the velocity is 0. So there you have that point. And when you have, let me extend this line a little bit. When you have the time equals to 3.06, that's back at the same place. There you have the velocity negative 15 meter per second. So there I mark this point over here. So now at this point, what you have to do is connect these dots. Well, that didn't really go through, so there I actually make it happen. So that's what that's what you have. So you see a slope that didn't change throughout the motion, and if you find this slope, you will end up getting a negative 9.8, or at least very close to negative 9.8 meter per second square slope from this graph. So as I said, once again, mark the coordinates. So here the coordinate is 3.06 and negative 15. And the coordinate over here is 1.53 and 0. And here the coordinate is 0 and 15. So this is how you mark the coordinates in the graphs, like, you know, in back in the school. And we follow the same thing. And this is how you set up the graph. Just to add a little bit to this discussion, what if you have something like, you know, a graph when something is falling down? So let's talk about that, like falling down object. Falling down object. So instead of throwing an object up, here you have an object coming down. So this is more like the second problem that we did in the class, but there you have an additional part going up, right? But here, now we are looking at just the falling part, right? So when something is falling, remember one of those keywords, the initial velocity equals to 0. And right at this point, you will definitely have a higher velocity, but pointed in the negative direction. Just for the fun of it, let's take this as negative 10 meter per second. That's the final velocity, okay? And then we have to do a calculation to find this height that I don't know. But if you are to ask, like, you know, if someone asks you to find the or get the displacement versus time graph for this one. So this is what we do. So here you have the displacement axis. There you have the time axis. Again, we mark the coordinates. So this is a 0, 0, the original point. When t equals to 0, where is the object? Well, it is delta y distance above the ground. So you mark that as delta y, right? And then from that time, what happens? The velocity is increasing, like, you know, the magnitude is increasing, but pointed in the downward direction, right? So here basically you have Vi equals to 0, then you have Vi equals to negative 1, then you have Vi equals to negative 5, Vi equals to negative 8, Vf equals to negative 10, right? So that's how it goes. So again, you see that the negative slope is increasing. So here you have no slope, a flat line, and then it is coming down like that. So here, just to know exactly what time that it strikes, you will have to use V initial, V final equals V initial plus A times T equation. And you can calculate the time here because you know Vf and Vi. You will most probably get something closer to 1.0 something. And then that is what you get, you put here. So for now, I am going to mark it as T. And the corresponding velocity versus time graph, well, I am drawing it like this because I know my initial velocity is 0. So this is at t equals to 0, when the time equals to 0, it is falling, right? So the initial velocity is also 0. So this is actually a point on my graph. When time equals to 0, velocity is 0 as well. And when time equals to 1 point something, when the time equals to t equals to 1 point something, I don't know that, we'll just do the calculation here and find it out. You will get a negative 10 velocity. So here we go. and just, get the numbers, right? And then here's the coordinate. And what you have to do is connect the dots. And this slope, one more time, should give you negative 9.8 because that is the acceleration that the object is falling down. And give me a minute, I will do a calculation and tell you what the t is. All right, so that time equals to 1.02. So we have that. So we don't have to leave the blanks here. So the time equals to 1.2 seconds. And then delta y you can calculate using the delta y equals v initial times t plus half a t square equation. So I believe that you have a good understanding at this point. And guys, expect something like this in the quiz tomorrow. Okay, good and good luck.